Success Path Tutors Scientia Ipsa Potentia.
Welcome to Success Path Tutors Chemistry video lecture series. I am KOLA AKINTUNDE. Today's topic is particulate nature of matter. What is a matter? A matter is anything that has mass and occupy space. Anything you can see around you, be it bottles, wristwatch, board, marker, and so on. And then matter. In matter, we see what we call molecules, and in molecules, we see what we call atom. So, a molecule is the smallest particle of a substance that can exist alone and still retain the property of that element. That is what we call a molecule. For example, if you have a matter this way, let's say, then you break it into pieces, then it will get to a stage whereby you cannot break it further. That smallest unit is what we refer to as molecule. Just like a dust of powder, you see that single dust is what we call a molecule. And inside the molecule we have atom. So atom is the smallest unit of an element which possess the property of that element and can partake in chemical reaction. So when we are talking about chemical reaction, that molecules A react with molecules B to give us C and D, it is atom that is reacting there. An atom, for example, you can have something like sodium atom, potassium atom, oxygen atom, and so on and so forth. And these atoms that we are talking about, we have some fundamental units in the atoms. We have so many units inside the atom, but there are three fundamentals, three important ones. Those are proton, we have the electron, and then the neutron. The proton is positively charged, the electron is negatively charged, while the neutron has no charge. There is no charge at all. And let me try to draw an atom for us, how an atom look like. Let's say this is an atom of anything, maybe sodium or potassium. This is an atom. And then in the middle, that is where we have what we call the nucleus. We have the nucleus of an atom there. And then we have the electron revolving around the atom. It will be moving around the atom. The electron is negatively charged, as I said. The electron is negatively charged. But inside this nucleus, in the middle, we have proton and neutron. Remember, I said the proton is positively charged, while the neutron have no charge. Let us take sodium atom for example. Now when you have sodium molecule, you know sodium have atomic number of 11, mass number of 23, so the atomic number of 11. So if you are drawing the structure in the K shell, you are going to have 2 electrons. In the L shell, you are going to have 8 electrons, and then in the M shell, you are going to have 1 electron. So this is a structure of a sodium molecule. So in this sodium molecule, then in this sodium atom rather, you have 11 electrons there. So if and you have 11 electron is 11, proton is 11, while neutron is 12. So while neutron is 12. Then let's move on to mass number and atomic number. This is how we represent an element. The mass number is going to be up here, while the atomic number will be down here. Mass number is represented by the alphabet A and atomic number by alphabet Z. So An atomic number is the number of protons that we have in an atom. Just like this structure of sodium, we have 11 protons. So this is the mass number, the number of protons that we have in an atom of an element. Then while mass number is the number of protons that we have plus the number of neutrons in the atom of an element. I said the neutron doesn't have any charge, while the proton is positively charged, then the electron is negatively charged. Basically, electron will determine the chemical property of a matter, while the neutron will contribute to the physical property of that matter, or let me say that element. So, for example, if you want to calculate the mass number of sodium, because the number of protons that we have there is 11, and then the number of neutrons that we have there is 12. So the mass number is going to be the number of protons plus number of neutrons. The mass number of sodium is 23. That is how we get the mass number of sodium to be 23. Then the next thing is that let's talk about ions. Now, what we call ions? Simply put, an ion is the number, or it is the atom that possesses electric charge, whether positive or negative. For example, we hear that we say sodium ion is a Na+, which means here we are telling you that the number of protons that we have, that is 11, but the number of electron is now 10. The number of electron is 10. So we have two types of ion. That how does this one come about? Because if it's something like chlorine, you can say for chlorine have atomic number of 17. So we say that the number of proton is 17, while the number of electron for the number of electron is the number of electron is 18, which means if you are calculating for a positive ion, then you are going to minus 1. Remember, the number of proton for sodium is 11 minus 1, then that will be 10 for the number of electron. Now, in chlorine ion, the number of proton is 17. Because it is negative, you add 1 to it, then that will be 18. Another example is, let's say for calcium ion, for example, calcium ion will give you Ca2+. So the atomic number of calcium is 20, which means the number of proton is 20. So now the number of electron, you just minus 2 from that 20, then that will be 18, and so on and so forth. So we said we have the two types of ions. We have positive ions, and then we have negative ions. Positive ions are formed when atom loses electron. That is what happened to sodium here, is that sodium has lost 1 electron from its outer shell. And what happened to calcium here is that calcium has lost 2 electrons from its outer shell. But if you are talking about negative ion like chlorine has gained 1 electron to its outer shell. So instead of it to have 17 electrons now, the electron is 18.
Okay.
Example of positive ions are something like sodium ion, calcium ion, then we can have ammonium ion, hydrogen ion, and so on and so forth. An example of negative ions are something like chloride ion, oxide ion, hydroxide ion, carbonate 4 ion, and so on and so forth. So next we are going to talk about what we call radical. What we call radical. Radical also is ion. So we can just say that radicals are a group of ions that are behaving as a unit. If you see these ions that we have here, you see that this one contains ion of a single element, this one contains ion of a single element, this one contains ion of a single element, ion of a single element, ion of a single element. Those ones we just call them ordinary ions. But ions that contain ion of two or more different elements, they are the ones that we call radical. Example, we have ammonium ion, we have thiazocarbonate 4 ion, hydrogen thiazocarbonate 4 ion, tetrasulfate 6 ion, and so on and so forth, because these ones contain more than one ion of elements. That is why we call them radicals. Atomicity. Atomicity refers to the number of atoms in a molecule of an element. You know, I told you that inside molecule that we have what we call atoms. So the number of atoms that we have in a molecule is what we refer to as atomicity. Let me say, for example, we can have sodium molecule. In sodium molecule, we have sodium atom. Let me put that in a table form. That here, okay, here molecule, then here atoms. Number of atoms that we have here. So for sodium molecule, we have 1 atom of sodium. In hydrogen molecule, we have 2 atoms of hydrogen. In oxygen molecule, we have 2 atoms of oxygen. In phosphorus molecule, we can have something like phosphorus 4. We have 4 atoms of phosphorus, and so on like that. So the molecule that we have just 1 atom inside it is what we refer as monoatomic molecule. Monoatomic molecule. The one that we have 2 there, we have diatomic molecule. If we have 3 molecules, just like in ozone, you know we have 3 molecules of oxygen in ozone, then we call that one triatomic molecules. And there's something like, when it is more than 3, like phosphorus 4, then we call that one polyatomic molecule. Polyatomic molecule. So we are going to stop here on particulate nature of matter, and in our next video we will continue and talk about isotopy. Thank you for watching.